All right, so this says study 2 patterns of dots. How are the number of dots in each pattern changing? So if I'm looking at the first one, I see that this one has 1, this one has 3, this one has 5, this one has 7. So it seems like it's going up each time by 2. I also noticed that the step number is also related to how many rows of 2 dots it has. So it has 1 row of 2 dots. Here it has 2 rows of 2 dots. Here it has 3 rows of 2 dots. And then each time it just has an extra dot here in the front. So I would describe this as adding a row of 2 dots each time, or saying something like the step number matches the row of 2 dots. So I'm on step 1, I have 1 row of 2 dots. I'm on step 2, I have 2 rows of 2 dots. I'm on step 0, I have no row of 2 dots. That is kind of how I would describe it. Now I'm being asked, how would you find the number of dots in the 5th step in each pattern? Well, I already said that I believe that the step number matches the number of rows with 2 dots. So 1 row of 2 dots, 2 rows of 2 dots, 3 rows of 2 dots, 4 rows of 2 dots, 5 rows of 2 dots, and then 1 extra. So let's count that number of dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That seems correct because from here I can see that it's going up 2 each time. So that means at step 4 it should have been 9, and therefore at step 5 it should be 11. So that seems correct. So for pattern 2, I go from 0, 1, 4, 9. Immediately I see something interesting, but I'll come back to that. So at step 0, I see 0. At step 1, I see 1. Like maybe I'll see 2 at step 2, but it actually goes to 4. So I have 1 at step 2. I have 1, 2 by 1, 2 in step 4. In step 2. And then in step 3, I have 1, 2, 3 by 1, 2, 3. So this is a 3 by 3 array. This is a 2 by 2 array. This is a 1 by 1 array. So if it's asking me what I think is going to happen or what pattern is current. So each step has as many columns and rows as the step number. So if I'm looking for step 5, then this is going to be a 5 by 5 array. So that answers number 1. How are the dots changing and what would happen on the 5th step? That answers number 1. Moving on to number 2. Number 2 says complete the table with the number of dots in each pattern. Okay. So I'm just going to fill this in and fast forward for the parts that we already know that are filled in. So now I have them filled up to the 3rd step, which is what we were given. But we also know the 5th step at this point. We know the 5th step because that is what we were asked to do in the last one. So we found the 5th step. The 5th step was 11 for pattern 1 and 25 for pattern 2 because it was a 5 by 5 array. So I kind of just need to fill in, well, what was it for 4? Well, again, I said that this one seemed to be going up by 2 every time, so that has to be 9. And this one, if it's a 4 by 4 array, 4 times 4 gives us 16. So then it's like, okay, well, how do we get all the way to 10? Well, we know that it's going to be 10 rows of these 2 dots. We know that it's going to happen 10 times, which is equal to 20. And then we just have to add that extra 1. So for 10, it's going to give us 21. Over here, we know that it's a 10 by 10 array, so we know that it's going to be 100. 10 times 10 is 100. But now it's asking us for this variable n. How can we find what's happening in the nth step? Well, it doesn't matter for pattern 1. It doesn't matter what step we're on. For pattern 1, it doesn't matter what step we're on. We always know that whatever step number we're at, which is what this stands for, N stands for step number. We know that whatever step number we're at, we're always going to add 1 to it at the end. And we're always multiplying that step number by 2 for the 2 rows, which is what we just did here. We multiplied 10 by 2, how many dots are in a row, and then added 1. So this is actually going to be 2n plus 1. Every single time we do that, it will work. So you should pause the video and then try plugging in 0 all the way to 10 and see, does it match what we have in the chart? Going back to pattern 2, this is what I said I kind of noticed before. 0, 0, 1, 1, 2, 4. As soon as I see 2, 4, I'm like, okay, that could be 2 times 2, or it could be 2 to the power of 2, which is still 2 times 2. But the reason that's important is because 3 times 2 is not 9, it's 6. But 3 times itself is 9. 4 times itself is 16. 5 times itself is 25. 10 times itself is 100. So here, this is actually the n step times itself. So whatever step you're on, which makes sense because we said it was a 4x4 array, a 5x5 array, a 10x10 array. And I could write this more simply as n squared, or you might know it as n to the power of 2. So that's number 2. Number 3, I'm going to pretty much skip through. It's just asking us to plot the points. So I'm literally going to be using just this section. Just this section here on this. So the step number, I have to look at my graph. It says step number here. So those are my x coordinates. And then on the side, it says number of dots. So that's my y coordinates. So 0, 1, 1, 3, 2, 5. Those are the coordinates I'm plotting. So that is the graph for pattern number 1. As you can see, I was asked to graph at 6, but we did not find 6 in our table. So I just used the equation that we came up with, 2n plus 1, and I plugged in 6 for my step number, and I got 13. And that makes sense because it's just add 2 to 11, you get 13. So that is pattern number 1. Pattern number 2, again, I'm going to do the same thing. I'm going to just skip through it. Okay, so as you can see, I have now graphed pattern 2. I paid close attention to the step number x and the number of dots y. It's important that you don't get those coordinates switched. Again, I was asked here to plot the step number 6, but we didn't know that. So I plugged it into the equation that we created, n squared, and I got 6 squared, which is 36. The only problem is that my y here only goes up to 30. So if I really wanted to plot 36, it would be all the way up here, which is why I said not plottable. But we still get a pretty good view of what this graph would look like. And that's 2.2. Please check back for another video about the next section, which is 2.3, expressing a growth pattern.